Your subscribe keeps us motivated. Subscribe now.
Tangential acceleration of a particle moving on a circular path of a radius 1 meter varies with time as shown. The time after which the total acceleration makes an angle of 45 degree with the velocity of the particle is, so you have to find the time after which the total acceleration making an angle of 45 degree with the velocity. Okay. So, first of all, you are given with a graph. If you are given with an AT graph, okay, if you are given with an AT graph, so let's see what we can understand from this straight line graph. If a straight line graph is there, then the equation satisfying this straight line graph will be y equal to mx plus c. And since it is starting from the origin over here, the c, y intercept will be 0, right? So, the equation will be y equal to mx, where y is the y coordinate, x is the x coordinate, and m is the slope of this curve. And how do you find slope? Slope of this curve will be tan theta. Theta is how much? 60. And tan 60 is nothing but root 3. This is our slope. If slope is root 3, let's design an equation satisfying this curve. So, what is our y-axis? Tangential acceleration at, and that will be equal to slope root 3. And what is x? X is time. So, our tangential acceleration is varying with time as this particular equation, equation number 1. So, at is nothing but root 3t, correct? And what is the tangential acceleration? That will be rate of change of tangential velocity dv by dt. So, dv by dt is root 3, correct? Now, we can find velocity from this. Yes. How do we find? Simply integrate both the sides. So, if you integrate both the sides, a dv integration will be equal to root 3t dt, correct? So, on integrating, we will get v equals to, taking root 3 outside, integration of t square by, this is our tangential velocity, okay? I hope this is clear. If this is our tangential velocity, let's figure out our another type of acceleration which is acting on a circular motion. And what is that? That is our centripetal acceleration. Centripetal acceleration is nothing but v square by r, where r is the radii of that particular circular path. So, AC will be equals to, what is v square? Let's go back. V here is root 3 t square by 2. So, root 3 t square by 2 whole square. This is our velocity. And what is our r? If you read the question carefully, the radius is 1 meter as per the question. So, if radius is 1 meter, then let's substitute the value of r as 1 in this. So, that will be the same thing. AC will be equals to 3 t to the power 4 by 2. This is our centripetal acceleration. Great. So, this is our centripetal acceleration, and that is our tangential acceleration at equation 1. Let me write as equation 2. The net acceleration will be, and both are what? Perpendicular to each other, right? Tangential acceleration and centripetal acceleration perpendicular to each other. So, the net acceleration will be A, and this A will be equals to, if the tangential acceleration is along x-axis, then centripetal will be along y-axis, you can say, or vice versa, anyhow you can. So, AT is nothing but root 3 t I cap. So, from where you got this? Equation 1. AT is root 3 t I cap, and AC centripetal acceleration is, just now we got a 3t4 upon 2 j cap, correct? I have done a small mistake here. When you square it, it will become 4 over here also. So, over here also 4. I hope this is clear. So, this is our net acceleration, clear? Now, velocity is always along the direction of tangential acceleration, because that's why we found the centripetal acceleration. That's how we found, right? So, let me write here, velocity is always in the direction of tangential acceleration. Tangential acceleration. Correct. So then we can say that our tan theta is nothing but the ratio of tangential acceleration to our radial or centripetal acceleration. Correct. And what is theta given as per the question? The theta is given as 45 degree, right? So this will be our tan 45 is 1. Tan 45, okay, let's write here tan 45 degree. And what is 80? 80 is root 3t upon centripetal acceleration, 3 to the power 4 and 4 goes on the top. And tan 45 is nothing but 1, and that will be 4 root 3 by 3 t cube, correct? And this implies a t cube is equals to 4 upon root 3, or this is equals to t equal to 4 upon root 3 whole power 1. So that is our answer, option B.